talking about?
This one.
This one? Okay,
Yes.
I can do that. So, in this question, just give me like 1 second, okay? I just need to do one thing. Okay. So in this question it says object O is printed document that includes a large letter R on side facing the lens and the top edge of the document corresponds. So tick one box indicate how the image appears on someone who's looking at the screen from the point P. Explain why image is this appearance. Okay. So first of all we need to see what is the image. Okay. So if you see that you had to make like like this. Oh no. Like this, and because this sort of thing, okay, so because you need to understand this is a real image because it basically forms like on the other side, right? So real image is always inverted as well. How inverted? It's like upside down. So R would be inverted like this. Okay, so it would look like this basically. Do you understand?
Okay, thank you.
Yeah. And then obviously it's a real image, so you can say it is inverted, and that's what you need to explain. Anyway, so today we are basically going to do spectacles, and usually I haven't seen any question related to this. Okay, but still it's in the course, so we gotta do this. Wait a second. Fine. So what happens is that short-sightedness is an issue where we say that a short-sighted person can see objects that are closer clearly and distant objects appear blurred. So that's an issue. So what you do is, like, for example, one way, like the rays from this is going here and here. So the eye cannot like bends, like it bends more than it should. So basically the image is not formed on the retina. So that's a big issue. Okay, so what you do is you put, to fix it, you need to put a glass, a diverging glass, so that when you put a spectacle like this, it would cause the ray to first bend out, like away, because it diverges, and then the lens of the eye is already bending it more than it should, so it would bend, and now it would, the image will be formed on the retina. Is it clear? So diverging lens is required to fix it. Like most of us have this issue, and older people have like long-sighted issue. Okay, so in long-sightedness what happens is that a long-sighted person, hello Caroline, how are you? can see distant objects clearly, but closer objects appear blurred. The reason for that is that when the rays come, the eye cannot bend it enough, and again they meet behind the retina. We got to fix it, and to fix it we got to use a converging lens because we need more bending actually. Okay, so what happens is this converges them more, and eye which is not converging them enough now converges like this. So that would cause it to fix. So we can say a converging lens can fix this issue. Is it clear, everyone? Any questions?
No.
Okay, good. Okay, please draw this and then we're gonna go forward. Right.
So can you please scroll down?
Like here or here?
So the above part. Also.
Okay, cool. So similar question like this is there, and it says which diagram correctly represent rays of light passing through the converging lens and on the camera. So yeah, right now the thing is that the camera does not really form in like it should. If it goes from the optical center, the rays should go straight and then they should make a smaller than actual size. So this should be the right answer. Why this is wrong? Because rays do not bend here, so that's absolutely incorrect. Rays bend before and then no bending here, absolutely incorrect. And here the rays are going again straight, they're not bending, that is absolutely incorrect. Is it clear, everyone?
So why is it small? Why is the image small?
Because the object must be beyond 2f. Okay, so when it's beyond 2f, it's the same. So camera and eye behaves the same way. Is it clear? Okay, then today we are gonna start with the electromagnetic spectrum. That was basically the main agenda. So electromagnetic spectrum has some properties. Okay, the first property is that they are all transverse waves. Number two, the next thing you guys need to remember is that they all travel at 3.0 times 10 raised to 8 meters per second in air or vacuum. Okay, and obviously they can travel in vacuum, unlike other waves that we know. All right. Okay, so one by one we're going to learn about them and write their uses and stuff. So you guys should focus here. So first of all, we got the radio wave. So radio wave is basically used in like radio and television transmission. They're also used in astronomy, and we generally use them to study the stars or other planets where the light is coming from. And also they're used in radio frequency identification, which is known as RFID, and these are like trackers. Okay, like we put, like if you go in a store, if you go in a store and you put it there, sometimes, yes, man.
What about radiotherapy?
Radiotherapy? No, that's not this wave. That is gamma, no?
Okay.
That is from radioactive. That word comes from radioactivity. Okay? That is used in gamma or X-rays, not this one. Okay? Is it clear? All right.
Yes.
So there are no dangers from radio wave. They're very cool in that sense. Then we got microwaves. Microwaves are like used in mobile signals. They're also used in satellites, which can, you know, give us satellite television, and they're used in cooking using microwave ovens. Now, the bad part about these are that they cause internal heating of body cells. So, how many of you puts food in your microwave oven and you basically do not wait for the timer to stop and you take the food out directly? Or have you seen somebody doing like that?
Yes. Yeah.
Yeah. The reason why it says like T at the end, because one, it needs to alarm you that okay, your food is now hot, you can take it out. The other thing is that at that time, until it doesn't stop, you should wait, because microwaves there are at high concentration, and you put your hands in, and that may cause, you know, internal body heating. So please don't do that. And somebody you see does that, also tell them not to do it. Okay, that's not good. Anyway, then we got infrared. Infrared is basically everywhere where there's heat, like electric grills. Okay, electric grills, and they're also used in remote controllers. They're also used in intruder alarms because they can, you know, sense heat. Heat wherever, yeah, like body heat releases infrared, and also thermal imaging. Like at night, you can see night vision, stuff like that, and also optical fibers. They're used in that. The bad part about them is that they cause burns, so because they're very hot, that's why.
So there's no disadvantage for radio waves?
No,
Yeah, no.
no disadvantage.
Okay.
Then we got visible light. Visible light has mainly, like, the only uses to see, to take photographs, and obviously to illuminate. Otherwise, it has no use, and there are no bad parts about this as well. They're very nice. Okay. So after visible light, you have ultraviolet, and ultraviolet, all these waves, gamma, X-rays, they're not very gentle. so you got to be careful around them. First of all, ultraviolet is used in security markings because they're not visible like some paints only reflect ultraviolet, so that's good. And it also helps in detects like fake currency. So in
Sorry, I didn't get the first part.
security markings are like, have you have you ever heard of invisible paint?
No.
No, there's a paint that's invisible, and you can actually cheat from that too. If you have a infrared like ultraviolet light, you can actually see that paint by shedding some ultraviolet. It would glow. You have no idea about that?
Some of the workers have those outfits.
Yes, outfits, exactly. They also glow because they have that special color on them, right? So for security, we can, put marks like so that normal light cannot detect or reflect from it. But if you see under ultraviolet, then you can see. All right, is it clear?
Oh, yeah, I remember that now.
Yes, it's like you can actually paint your body with it. It's not visible unless you go into ultraviolet light, and then everything is visible.
Yeah.
Then it can also be used in sterilizing water, and because it kills a lot of germs. But it has some bad parts about it as well. First of all, it can cause damage to surface cells, usually skin, right? And you can then it can lead to skin and eye condition. And this is the reason when you buy like sunglasses stuff, it's written UV protection, and you buy special creams that's also say UV protection, right? So sunblocks have it because it's not actually blocking the sun, it's blocking like ultraviolet to get into your skin. Is it clear?
Yes, sir.
Then you got X-rays. X-rays have um, they're very useful actually because they're used in medical scanning, like if you have a broken bone or something like that. Also, it is used in airports where it can be used in security scanning as well. But you guys need to remember that ultraviolet is radioactive. Because it is radioactive, that would mean that it can basically causes mutation. Mutation is like um, improper functioning of cells and damage to cells. All right, so they can change the DNA. The gamma ray are also radioactive, very very dangerous and very very useful as well. So they're used in sterilizing foods. They're also used in sterilizing medical equipment, like in the hospitals when if you have you seen those ads of like soaps and stuff, they say kills 99.9% of germs. Have you seen those ads?
Yeah.
Have you ever wondered why that doesn't kill 0.1% of the germs?
Yes.
Because some germs from the soap cannot be killed, so only they can be killed through gamma rays, and gamma rays are very very tough on them, so it can cause damage to all living cells, right? That's why you use these are used in like to sterilize the medical equipment, because that's used in operating patients and stuff like that. And then it is also used in detecting cancer It is also used in treatment of cancer, and that's basically radiotherapy. It has nothing to do with radio waves. Okay, is it clear, Iman?
Yeah, sure.
But
So,
yes,
so does it help in identifying the cracks in the pipes?
yes, it can do that as well. It can actually be used in identifying. Okay, identifying small cracks, that it can do because it is very penetrative. That's why it also causes mutation and damage to body cells. So people who undergo treatment of cancer, you might have seen that their body would undergo changes, like their hair would go away, right? So because gamma rays kill them, and they can also damage normal cells and uh, the bad cells, cancerous cells. So it takes a while to, because ultra gamma rays are like shed on a very specific part where cancer is, because it can damage normal cells if we just expose the patient throughout. Is it clear? So it's something that can cause cancer, and it is also something that can treat cancer. Very cool of it. Anyway, now when you go from, like we've done in series, when you go from radio wave to microwave, you guys need to understand that the frequency increases and wavelength decreases, which means that radio wave has highest lambda and lowest frequency, and gamma has highest frequency and lowest wavelength. Is it clear, everyone? Okay. Any questions, please let me know. Okay. All right. Now going to the next slide. So for the first question says, what is the speed of X-rays in vacuum and in air? So X-rays are this. What do you think should be the answer?
D.
Yeah, they have the same speed. Very good. And let's go to the next page. Who can tell me the two uses of infrared radiation?
Electric grills and remote control.
Yeah, very good. And then says X-rays are used in hospitals to treat patients. Suggest and explain 3 precautions. So the 3 precautions are that you should not be exposed to them for very long. This part we will also do in radioactivity, which is the last chapter as well. So I'm just going to tell you right now that you have to keep minimum exposure. You need to handle things with gloves, and you need to then make sure that when you're doing it in the hospital or something, you should be away from the area where there is targeting of X-rays. All right, so you should be doing that. Generally, you would want to use a suit, which is a lead suit, to protect yourself from radioactive it being penetrating to your body. But
So can you repeat?
like you can use a lead suit. Okay.
Yes.
You can basically limit exposure, right? And while handling it, do not use gloves, etc. All right, is it clear? And safe handling requires, and you should not be right standing where the patient is. That would cause you harm. Okay. State the speed of vacuum. You already know they have the same speed. State the possible frequency of ultrasound. Okay, this is from sound. We're gonna do later. Okay. And Who can tell me this quickly, please? I'm going to give you this homework as well. What do you think A is?
Infrared.
Infrared. And what do you think B is?
Ultraviolet.
C?
X-ray.
Yes. And D is gamma. Very good. So easy, right? This is so easy. Which type of waves are produced by television remote controller? What? Infrared. Very good. Which statement? No. It has to be A only. Remote controller has infrared only. So homework. And this one is homework as well, because this is very simple. And homework as well. Same, like they don't have many questions about it, so you guys can chill out. Same goes here. Homework. Very easy question. And now we're gonna go towards dispersion. Okay. So dispersion of light is basically when light goes through a prism. This is white light. The white light basically spreads into its 7 colors, which is from red to violet. So you guys need to understand that the colors, like the red has like the lowest frequency and violet has the highest frequency, which means frequency is increasing, and red has the highest wavelength amongst them, and lowest wavelength violet has the lowest. Okay, so frequency increases and wavelength decreases, so you guys need to remember that. Okay, let me write it here. Increases and decreases. One thing that I want to tell you is you got to understand, note here, that the light disperses as soon as it enters the glass block. Okay, and the other thing you guys need to understand is this is due to different speeds of colors, okay, in the medium. So they just spread, and if you notice, red spreads the least and violet the most, and all the colors like that. Alright, so you got to remember this. Is it clear, everyone?
Yes, sir.
Just remember this. Now then it says define monochromatic. Mono means single, chroma means color. So monochromatic means light of single frequency, or you can write wavelength. Alright, so that would mean just a single color amongst these. Is it clear, everyone? Then it says which statement describe monochromatic light? What do you guys say?
B.
B, very good. So it's pretty easy like that. And then I'm gonna go forward. So in this question, let me see if it's so I want you guys to, this is from the light, so I want you guys to do this, but I'm gonna do the other one. It says on figure 6.1, draw refracted ray XY, ray emerging from phase Z, and label ray R. So whatever angle is this, you're gonna do like this. It's gonna bend a bit, and then you're gonna draw a normal line and bend a bit more. Okay, then says a ray of blue light follows the same path of red light. Oh no, this was the red light, sorry. So let's color it red. Color red. Okay, if it was blue light, then obviously the blue light will, if it's coming from the same path, it will bend more than red. So this will be red, this will be blue. Is it clear to everyone? Like that. You got to label it B. Sorry. Oh, we have done it already. Very nice. Okay, is it clear, everyone? Any questions? Anything you think is difficult here?
No.
Okay, very good. So then we're gonna go to the next part. You would have to do it on your own because this is very simple again, very simple, from the previous chapter as well. Homework, because the more you practice this one, this is just like uh, you just read the notes and you will be able to do this. And if you don't understand something, do let me know in the next class. This is the same question. So the same type of question they keep on asking, keep on asking, keep on asking. So you don't have to worry about that. Finally, we are gonna be at the uses of microwaves, which was recently introduced. So we got to do that. So first of all, satellites, artificial satellites are using microwaves all the time. So there are two kinds of satellites. There are low orbit satellites and geostationary satellites. So about geostationary, I just want to comment two things. I want to tell that they revolve with the same speed as Earth. So if Earth is revolving at the same rate, they also revolve together, and then also in same direction. So that is the reason that these kind of satellites are called geostationary, which means it seems like they're just at one point, but they're not. They're just moving through, like in synchronization with Earth. So it seems like they just are at one point. All right. And then low orbit satellites, they just move everywhere. So you guys need to understand that. So some mobile phones use low orbit satellites and some use geostationary. So it depends on the function. So whatever satellite is near to them, they just use that generally. So yeah. Anyway, so basically, what we need is we need it for communication, obviously, for the mobile phone. So for communication, number one, we need to understand that microwaves are good at penetrating most of the walls. That's how mobile signals reach your house. And the other thing is that you should remember that microwaves require only short aerial for transmission and reception. Now, what is an aerial? Uh-oh. So basically, it's like this. There's a tower, and then there's a satellite. So the signals are sent, and then maybe at some distance, really far away, signals can be captured like this from the other aerial. Is it clear, everyone? Now you have Bluetooth that you have in your phones. They're also microwaves, and some use radio waves as well. So if it's a good Bluetooth, it uses microwave. If it's a cheap one, it uses radio wave. So it uses a low energy radio wave or microwave because they can pass through walls, but signals are weakened. So if you go away, then it's not very effective, and that is the reason Bluetooth is you do use it within the same room and at the same short distance, right? So you can write this down. Let me know if you have any questions. All right. Then we got two types of signals. So we got analog signals, which are basically continuous signals of any wave. You want me to go back? Okay.
Yes.
Yes. Okay. All right. That's pretty good. Now, okay, pretty good. So then what you're going to do is um, there are two types of signals, analog and digital. Analog signal means they're continuous signals, and they can basically radio waves and um, gamma microwaves are used in this. Um,
So
digital
what do you
are,
mean by a continuous signal?
I'm going to tell you in a bit, okay? So digital signals are discrete time signals generated by digital modulation, okay? They only have highs and lows. Now let me tell you. So an analog signal looks like a wave. Obviously, wave has all sort of like wave has different energies at different point, right? So, but digital has like one or zero only. So one is called high because computer only understands zero and ones, right? So computer changes the signal into digital one. Do you understand? Analog signal means all of them, like you have various values all over the wave. They're just not one or twos. Is it clear?
So that's what it means by continuous signal.
Yep, this is what it means continuous signal, right? That it is not like it has many numbers like 1, 2, 3, 4, 5, whatever. But digital one has only two, zero ones. Is it clear?
Yes.
So computer only understand one means on, zero means off, and computer understands that. So computer changes this wave into a digital one first by digital modulation, and then send that address to the next computer, which it can interpret and create the wave again like that. So the main difference between analog and digital signals are, number one, as you already know, this is like continuous signal. This is discrete signal. Number two, these are represented by sine wave. As you can see, from sine wave is like this, and these are represented by square waves. Square waves are like 0, it could be 1 1 and then 0 and then 0 0 1 1 0 1, like this. Do you guys understand that? Like this. And then every natural like voice, every natural wave is an analog wave. Like my voice is like analog. Any natural sound you see is analog. And obviously analog electronic devices, anything that naturally exists has analog wave. But for digital, you got to convert this. So computer, optical drives, and other modern electronic devices uses digital signal. Okay, now, so it has like continuous range of values. Like I told you, it could be like 1 2 3 4 5 6 7 8 9 10 11 12, whatever, right? Every value has like a number behind it, but it is like only like zeros or ones, which means highs or lows. That's what it is. Then when continuous analog wave is basically records the sound waves as they are. So whatever I'm speaking, the analog wave is just the same as it's coming from my mouth, my throat, really. But digital basically converts into a binary form. Binary means 0 and 1s only. Then they are used only used in analog devices, and these are suited for digital electronics such as computers and mobiles, etc. All right, the new devices. Now the thing is, if we can get around with analog, why do we need to have this hassle to convert analog signal to digital? Because they have many benefits. One benefit is that it has an increased rate of transmission of data, like through digital signals, because we have converted into zeros and ones only, so it's easier for it to be transmitted and at a faster rate as well. Okay, then the signals can be regenerated when it is sent at a long distance. So I'll show you how this point, just hold on to it. And the third thing is that digital signals are more secure. So it is very difficult for people to hack in. Analog can be tapped, but digital signal cannot be tapped that easily, right? So it's better. Like WhatsApp calling is secure because it is encrypted sort of in a digital signal and people cannot know, but normal calling is not, which might be a problem. Okay, like that. Alright, you guys have written it. Should I go forward?
Sir, can we say that it takes up lesser storage?
Replace what?
It takes lesser storage.
Lesser storage? No, we can't say that. So the amount of information is the same, but information can be sent quickly. Do you understand?
Okay, sir.
Yeah, they're different things. Alright, then going to the next one. So I'm just going to explain the point which I wrote, that the signals can be regenerated. So let's suppose there was an analog signal, and between this there was noise. Noise means any interference, like there could be somebody, already you were talking on the phone, and then somebody is also talking on the phone from some other line, or maybe there is like electrical interference, magnetic interference. So there's noise. What happens is that this causes the signal to become clouded and disturbed like this. Noise meets, and now when you get it from the other end, it basically is not very nice. Do you understand? So you have no choice just to listen like this, because you cannot regenerate it. So what happens is that when digital signal goes through a long distance, so there is also noise, but the digital signal gets like clouded, like even if it's clouded really badly, still, because you know the actual highs and lows, you know it is 1 0 1 1 0 1 1 0 1 0 1, so you know the actual numbers. So what you can do is you can regenerate it again. Do you understand this? Like this, because the computer knows that this is a high, this is a low, this is a high, this is a low, so computer can regenerate and you can get a very nice sounding voice. Like I'm talking to right now, you guys are sitting like, I don't know, maybe in Dubai, maybe in Saudi, maybe in Oman, wherever you are, and from Pakistan I'm talking to you, and you can hear my voice clearly. If this was an analog signal, you would not be able to hear my voice very clearly. Is that clear, everyone?
Yes.
So this can be regenerated, and that cannot be. So that's one of the uses, right? So I don't think so there's anything else. That is all, my friends, that we're gonna do. And I hope you have understood this, and if you've got any questions, to let me know.